Hi everyone. Today we're going to study direct trigonometric functions or ratios. We have here a right triangle. First, let us label the parts of the right triangle. We can see here the small square that denotes right angle, and the side opposite is what we call the hypotenuse. Then, for the two angles here, let us name one angle to be theta, and the side here is the opposite side of theta. And the last side will be called the adjacent side of the angle theta. We will now specify direct trigonometric functions. We will begin with the sine theta. The symbol for sine is sin theta, and this is equal to the ratio of the opposite side over the hypotenuse. The next function is cosine theta. The symbol is cos, and this is the ratio of adjacent over the hypotenuse. The next function is tangent theta, and the symbol is tan. This is the ratio of the opposite side over the adjacent side. There is a popular mnemonic to help us remember quickly the three functions here. This is the so, ka, towa. The SOH is for the sine. The S here is the first letter of the sine. The O is for the opposite, and the H is the hypotenuse. The ka is for the cosine, with that first letter C to denote cosine. The A is adjacent, and H is the hypotenuse. Towa is for tangent, where T is the first letter of the tangent. The O is the opposite, and A is for the adjacent side. So katowa. We'll go now to reciprocal functions. Let's begin with secant theta with a symbol SEC, and this is the ratio of hypotenuse over the adjacent side. This is called reciprocal function because this is the reciprocal of cosine. The next function is cosecant theta with a symbol CSC, and the ratio is hypotenuse over opposite side. This is the reciprocal of the sine. The next function is the cotangent theta, symbolized by COT, and this is equal to the ratio of adjacent over opposite side. This is the reciprocal of the tangent. Let us have example 1. Using the triangle shown below, evaluate sine alpha, cosine alpha, tangent alpha, secant alpha, cosecant alpha, and cotangent alpha. In this triangle, the angle alpha is here. So the opposite side is here with a length 4. This is our right angle, and opposite to that is the hypotenuse with length 5. And the side here is the adjacent side with length 3. Let us now start evaluating the ratios. Let's begin with the sine alpha. The ratio is opposite over hypotenuse. The opposite is 4 and the hypotenuse is 5. So this is 4 over 5. Next is cosine alpha. The ratio is adjacent over hypotenuse. The adjacent side is 3 over the hypotenuse, which is 5. So cosine alpha is 3 over 5. Next is tangent alpha, and the ratio is opposite over adjacent. The opposite is 4 over the adjacent, which is 3. So tangent alpha is 4 over 3. Next is secant alpha. The ratio is hypotenuse over adjacent. Hypotenuse is 5 over the adjacent, and that is 3. So secant alpha is 5 over 3. Next is cosecant alpha. The ratio is hypotenuse over opposite. Hypotenuse is 5 over the opposite, which is 4. So cosecant alpha is 5 over 4. Last is cotangent alpha. The ratio is adjacent over opposite. Adjacent is 3 over the opposite, which is 4. So the cotangent alpha is 3 over 4. So we are now complete with our ratios. Let us have example 2. Given the triangle shown in the figure, find the values of all trigonometric ratios or functions of the angle alpha. The angle alpha is here. We have the length of two sides, 15 and 8. The length of one side is missing. That side is the opposite of the right angle, and that is the hypotenuse. So first, we will calculate for the hypotenuse. We will use the Pythagorean theorem. We will assign letter C to the side which is the hypotenuse, and the formula will be c square equals a square plus b square. Substituting now the values, we have the c square equals 15 square plus the 8 square. Simplifying further, the 15 square is 225 plus 8 square is 64. Then we will add the two numbers, it becomes 289. So c square equals 289. We will get the square root of both sides. Only c will come down here, and we will take the square root of 289, which is equal to 17. So the value c is 17. Then we will start writing our trigonometric ratios. Let's begin with the sine alpha. We know the ratio is opposite over hypotenuse, and that is equal to 8 over 17. The next is the cosine alpha. The ratio is adjacent over hypotenuse. The adjacent is 15 over the hypotenuse 17. So cosine alpha is 15 over 17. The next is the tangent alpha. The ratio is opposite over adjacent. The opposite side is 8 over the adjacent, which is 15. So tangent alpha equals 8 over 15. The next is secant alpha, and the ratio hypotenuse over adjacent. The hypotenuse is 17 and the adjacent is 15. So secant alpha equals 17 over 15. Next is cosecant alpha, and the ratio is hypotenuse over opposite. The hypotenuse is 17 over opposite, which is 8. So cosecant alpha is 17 over 8. Last is cotangent alpha, and the ratio is adjacent over opposite. The adjacent side is 15 over opposite, which is 8. So cotangent alpha is 15 over 8. We have now written all the trigonometric ratios, and this is now the final answer. I hope you learned something from this video. See you again next time.